We will now evaluate this f prime of 3, which is basically the derivative of the function f of x at the point x equal to 3 using the definition of derivative. So here I have given the definition of derivative, which says that if you have to find the derivative of a function f of x, which is denoted as f prime of x, this is equal to limit of f of x plus h minus f of x over h, and h approaches 0. So let's use this definition of derivative to find f prime of x. So this is equivalent to, I'm using this definition. So I put this limit of h approaches 0, and then we have to put limit of, f of x plus h. So we have been given f of x as 2 over x minus 1. So this is basically a rational function. So to find f of x plus h, all that we do is in place of x, we replace it with x plus h. So therefore this becomes 2 over x plus h minus 1. I put this inside a bracket, and then we have negative f of x. So I put the f of x as it is. So therefore I can write down, 2 over x minus 1, and all over h, because we have h in the denominator. So this is what we have to write in the first step. Now we have to simplify the numerator. It's a kind of fraction. We have two parts with the rational functions. So let's simplify them first. So I write down limit of h approaches 0. Notice that the least common denominator of this fraction is the product of these two terms, that is x plus h minus 1 is one term, and another term is x minus 1. So this is basically the LCD to simplify the numerator fraction, which means for the first term, that is 2 over x plus h minus 1, I'm going to multiply with the term which is missing in the denominator. So in the denominator, I have this term x plus h minus 1, which means I can multiply that fraction by only by x minus 1. So let me do that. So therefore, this will be equal to x plus h minus 1 times of x minus 1 over x minus 1. And similarly for the second term, the term in the denominator is x minus 1, which means we have this term, so we have to multiply only with this term. So we can write down this as 2 over x minus 1 times of x plus h minus 1 over x plus h minus 1, and all over h. So we put like this. Now let's simplify the terms. So therefore I can write down this as limit of h approaches 0. Now we multiply the numerator as well as the denominator. Here also we multiply the numerator and also the denominator. So therefore this becomes 2 times of x minus 1 over x plus h minus 1 times of x minus 1. And for the second fraction we have 2 times of x plus h minus 1 over x plus h. I rewrite at x plus h minus 1 as the first term, and multiplied with x minus 1 all over h. Now we can clearly see that we have a common denominator, so we can combine these two fractions just by adding the numerator parts. So I can write down this as limit of h approaches 0, 2 times of x minus 1 minus of 2 times of x plus h minus 1 over just one denominator, that is x plus h minus 1 times of x minus 1. This time I'm going to put this all over h's multiplied with 1 over h. So we can write down like this as well. Now let's simplify the numerator parts. So this is equal to limit of h approaches 0. We just have to distribute this 2 with x minus 1. So when we do that, I get 2x minus 2. And then we have to distribute this negative 2 with the 3 terms inside the bracket. So therefore it will become negative 2x, negative 2h, and negative 2 times negative 1 is positive 2 all over. We have this x plus h minus 1 and x minus 1 term in the denominator multiplied with this 1 over h. Now we can simplify. We can see that we can cancel some of the terms. This 2x and negative 2x will get cancelled. Minus 2 and plus 2 will become 0. And finally, we are left out only with negative 2h, which means we can cancel this h with h as well. So finally, it becomes only negative 2 in the numerator. So I'm going to rewrite. Therefore, this simplified form is limit of h approaches 0 minus 2 over x plus h minus 1 times of x minus 1. Now we can do the substitution for h equal to 0, which I'm going to make. So it becomes minus 2 divided by, in place of h, I have to put 0. So therefore, this becomes x plus 0 minus 1 times of x minus 1. So this is equal to negative 2 divided by, this is 0, x plus 0 minus 1 is equal to x minus 1. And then we also have one more term. So product of the two similar terms will be the square of the term. We can put this as x minus 1 quantity square. So this basically represents the f prime of x. However, we have to find f prime of 3. So what this means is we have to replace x by 3. So to find f prime of 3, since we got this as the expression for f prime of x, which is the derivative of f of x, now we find f prime of 3, which is the derivative of f of x, evaluated at x equal to 3. So therefore, I'm going to replace x by 3 here and then simplify. So this becomes 3 minus 1 quantity square. This is equal to negative 2 divided by 3 minus 1 is 2. So it becomes 2 square. So we can cancel negative 2 by 4. And this is equal to, if we reduce the fraction, negative 2, or we can write down in decimals as negative 0.5. So the answer for this question is, we have evaluated the derivative of the function evaluated at x equal to 3. It is negative 2 or negative 5.